All right, let's get started. We are doing 8.5 today. What are we? Math 54, trigonometry. 8.5 is on the polar form of complex numbers. Or trigonometric form. Of complex numbers. So. You've often seen them in the form of A plus BI. The real component, the imaginary component. And we've never actually really graphed them. So the way we graph these. We graph these by making. The x-axis. Be the real axis. Button's over here, it's beeping at me. And the y-axis is the imaginary axis. And when we set up the graph that way. We call this the complex plane. And each complex number. Can be graphed as a vector. Starting at the origin. And terminating at AB. So if I wanted to plot, I don't know, let me put some hash marks on here. If we did something like 2 plus 3i. What I'm doing is I'm going right 2 and up 3. And that represents our 2 plus 3i. I'm gonna have like -4 plus 2i. And when we do it like this, vector addition works. If I add these up, I get -2 plus 5i, which is a vector going to there. Which is the same thing as going along either of these vectors and adding the other vector to it tip to tail. Or tail to tip, tip to tail, tip to tail. So this is like doing the 2, 3 vector. And doing it like this makes working with complex numbers a little bit easier. Multiplication and division for complex numbers was a pain in the ass, though. I don't know if any of you remember it. We'll take a look at it in a second. Just as a refresher on it. This representation, this geometric representation is called. The rectangular form. Or standard form. And then let's refresh our memory on how addition and subtraction is pretty easy with complex numbers. Let's refresh our memory on multiplying and dividing. If I take -4 plus 2i and I multiply it by 2 plus 3i. We basically have to FOIL. We've got -4 times 2 is -8. -4 times 3i is -12i. 2i times 2 is plus 4i. And 2i times 3i is plus 6i squared. Does anyone remember what I squared equals? It equals -1. So maybe we better talk about the powers of I. I is the square root of -1. So I squared is -1. I cubed is the same thing as -I, or negative square root of -1. And I to the 4th is I squared squared, which is +1. And it starts to cycle. I to the 5th is the same thing as I to the 4th times I, which is just I. So it starts going in a loop. These 4 make a cycle. The cycle of I. I, -1, -I, +1. But since I squared is -1, I'm gonna put the -1 there. So that makes this -6, 6 times -1. And when I combine like terms, I've got -8 minus 6 is -14. And then -12i plus 4i is -8i. This is all just refreshing algebra shit, other than maybe showing you the complex plan. Folks who are still waiting, just hanging there patiently. Let's take a look at division. This is the same thing as having a denominator of 2 plus 3 square root negative 1. Does anyone remember what we do when there's radicals in the denominator? We could multiply by the radical, but when there's a plus sign or when there's two things on bottom, we gotta do the conjugate. The conjugate is change the sign on the one with the radical. Kind of thing, or on one of them. So what we're gonna do is multiply this on top and bottom by 2 minus 3i. This is effectively a plus b times a minus b on bottom, which is a squared minus b squared. Which means we get 2 squared minus 3i squared on bottom. And on top, we multiply that out. We have -8 plus 12i plus 4i minus 6i squared. Let's see if we clean this up. This is 4 minus 9i squared. But I squared is -1. So this ends up being 4 plus 9 on the bottom, which is 13. And the 6i squared, -6i turns into +6 after we turn the I squared into -1. And we get -2 plus 16i on top. So if we wanted to write it in the form that looks like the other ones, we just split it up into 2 fractions. This is not the most fun thing to do. Let's look at this in terms of trigonometric form or polar form. Yeah. A plus bi is kind of like the same thing as x plus yi. Now, when we were looking at a triangle. We treated this as a unit circle, this is R. And the x value ended up being R cosine theta. The y value ended up being R sine theta. Remember all this? I hope so, this is what we've been doing this semester. Well, let's take those and plug those in up here. If I do, I've got R cosine theta plus R sine theta times I. So the way we tend to write it is we factor out the R. And we put the I in front of the sine theta. So we could, this is called the trigonometric or polar form. And this thing is often abbreviated as R cis theta. CIS is cosine I sine. They've been using this a lot longer than society has been using the word cis. Like this shit's math, this shit's hella old. This, yeah.
I was gonna say, so it represents the equation, so it's actually saying CIS is cosine plus I sine?
Yeah, so CIS theta is short for cosine theta plus I sine theta. And it comes from the C, the IS. So there's gotta be a way for us to switch from our rectangular form to our polar form, and we've done this with other things. We haven't really looked at it that much, thought about it out. We need a way to get R from XY and we need to get a way to get theta from XY. If we wanna get R from XY, well, we had X equals R cosine theta. And Y equals R sine theta, I'm writing like this so we can have it all together here. We have seen that when we did x squared plus y squared. Which is r squared cosine squared theta plus r squared sine squared theta. We get r squared cosine squared theta plus sine squared theta. We've done this before, I'm just refreshing your memory on it, it's been a while. Cosine squared plus sine squared is 1. So we get x squared plus y squared equals r squared, it makes sense, it's a triangle. This is the Pythagorean formula. So r has to equal the square root of x squared plus y squared. What's wrong, Davis? So to get that, I basically took these and plugged them in here. And the other thing we have, if we wanted the angle theta and we want it in terms of x and y. The function we have that works well with that is tangent theta. Tangent theta equals y over x. As long as x does not equal 0. So that's the set of switching back and forth between rectangular form and trig form, polar form. Let's do some examples with it after everyone's had a chance to write this shit down. Guys ready? So probably the easiest problems to start with is let's start with polar, end in rectangular. So let's have 10 cosine of 135 degrees plus I sine 135 degrees. So to go to rectangular, we need to convert these to values. What is cosine of 135 degrees? It's negative root 2 over 2. Excellent. What about sine of 135 degrees? It's positive root 2 over 2. So if I distribute these, I'm gonna get negative 5 root 2 plus 5I root 2. Some books you'll see this right, or some people write it with the I at the end. That way it looks more like an A plus BI. I tend not, I put the I in front of the radical, that way there's no confusion on where I is. I hate having shit after a radical sign. Cause you're like, is it under the radical or not? You know what I mean? And if you're writing quickly, it gets sloppy and you're like, all of a sudden, I don't know where that thing is. Is it part of the square root or not part of the square root? in terms of looking at that. This is like rotating 135 degrees. And then going out a distance 10. Based on the polar coordinates. And when they write polar coordinates, they tend to write r comma theta. So this would be listed as 10, 135 degrees. And we'll do a lot more of that in 8.7. A whole lot. This is a glimpse at 8.7. And then in our other coordinate system, this is -5√2 going this way, and this is 5√2 going this way. This is the real axis, and of course, the imaginary axis. Let me give you guys one to try to translate. 3 cis 60 degrees. Try to figure out how to do that. So we write out what that is. That's 3 cosine of 60 degrees. Plus I sine 60 degrees. What is cosine 60? 1/2. And sine of 60? 3/2. So we get 3/2 plus 3i√3/2. Not too bad, right? Alright, going the other way. We'll do more with the polar coordinates later, because that is a whole section, so. Just wanted to give you a visualization. So rectangular to polar. So what you wanna do is you wanna do a quick sketch. At least enough to know what quadrant it ends up in. Right? Then we're gonna find R. Using the square root of x squared plus y squared. And C, find theta. Using. Tangent theta equals yx. And quadrant from part A. So let's do some examples. Let's start with 8 minus 8i. So if I do a quick little sketch of this. 8 in the real direction and -8 in the imaginary direction is like that. So we're looking at quadrant 4. This is like x plus yi, so x equals 8 and y equals -8. So r is gonna equal 8 squared plus -8 squared. Which equals 64 plus 64. Or I'm not gonna add them together, I'm gonna treat this as multiplication. Cause then I can break that up and make that into 8 root 2. Then we look at tangent theta. Tangent theta has to equal y over x. Which is -8 over 8. Which is -1. Where does tangent theta equal -1? Quadrant 2, 4, at what degree or what angle? It's got a reference angle of 45. So that would be 135 and 315. We're in quadrant 4, so we want that one. So 8 minus 8i. Is the same thing as 8√2. Cis 315. Take a look at another one. -15. That's it. If I wanted to see the I, what would I put? 0i, right? This is like -15 plus 0i. Which means we're just down 15, right? Straight down -15. Not degrees, just -15.
Yeah.
What?
Wouldn't it be less than 7?
You're right, is. Look at me fuck that up like a champion. Do I need tangent theta for this? Right? When it's on one of the axes, this is a multiple of 90 degrees, what is it? 180. Save yourself some effort if you can. Radius should be pretty easy here too. It's just 15. It is positive. If you wanted to see it, r equals the square root of -15 squared plus 0 squared. Which is the square root of 225, which is 15. Radius is always gonna be positive. Alright, let me give you guys one to do. We only have 3 lectures left after this, we'll be done before Thanksgiving on the lectures. I got 2 next week and 1 on the Monday before Thanksgiving. Which means the semester's almost over. If you're struggling, don't forget, I'm at the Mesa Center on the weekends from 8 to 2. Jordan and Keith are always there, David shows up sometimes, he tries to get there, but. Oftentimes, I'm not even doing a lot, they're working together, coming up with problems, doing homework together, they made their own study group together on the weekend. And I'm sure they wouldn't mind adding it there to report. Alright, what quadrant are we in?
3,
We're in 3, right? -3 and -4. So x here is -3 and y here is -4. So r. -3 squared plus -4 squared. Is 9 plus 16. 25, which is 5. Fortunately for theta, I don't know what this one is. Theta is gonna be tangent inverse of -4 over -3. Which is tangent inverse of 4/3. And that requires a calculator. So sometimes you'll need a calculator going both directions on these, either direction on these. So we'll do tangent inverse. 4/3. And I am getting, this is gonna give us the reference angle. Is 53.13 degrees. Now, in terms of my picture. That's my theta hat, that's the 53.13 it's giving me. So what is theta actually?
that plus 180, so 233.
Yeah, we gotta add that to the 180. We're getting 233.13. So R equals, not R, -3 minus 4i. Is equal to 5 cis 233.13. And this is a good spot for taking a break, let's take a 10-minute break. Alright, so. We showed how you multiply complex numbers. In rectangular form. How do we multiply complex numbers in polar form? If we have R1 cosine theta plus I sine theta. Times R2. Let's call it theta 1 on this one and theta 2 on this one. And maybe I should put those in parentheses like a good little math teacher. It turns out when you work this all out. This is R1 times R2. Cosine of theta 1 plus theta 2. Plus I sine theta 1 plus theta 2. Or if we look at it in the cis version. R1 cis theta 1. Times R2 cis theta 2. Equals R1 R2. Cis. Theta 1 plus theta 2. So we multiply the coefficient or multiply the radius. Or plural of radius is radii. Of radius. And add the angles. Yeah,
This represents us. Okay, yeah, like, it's graphs.
that was added.
That's added, this.
This was like when we did. We actually wrote it out, we had 2 plus 3i times -4 minus 2i. It's doing that one, but in polar form. So this one actually wasn't too bad. Like foiling isn't too bad, doesn't take that long. But on our first example, let's do both forms and make sure it works. Let's make sure I'm not making shit up. Cause we know I'm pretty shifty. So let's use 4 cis 120. And 5 cis 30. So we're multiplying these, 4 cis 120. Times 5 cis 30. We do 4 times 5. And then we do cis of 120 plus 30. Now, I'm sure you can jump to this in one step, but I wanna make sure I'm writing it out. So we've got 20 cis 150 degrees. So multiplying these in polar form is really fucking easy. As long as you remember how to do it. Well, what would this be? This is 20 cosine of 150. Plus I sin, or 20i. Sine of 150. What is cosine of 150? This is -√3/2. She keeps beating me, Gordon.
My hands.
What's sine of 150? 1/2. So if I multiply 20 by each of these. I get -10√3 plus 10i. Does that work if we shift it to rectangular and get the same thing? Let's check it out. So what is 4 cis 120 in rectangular? We got 4 cosine 120 plus 4i sine 120. What's cosine 120? Got a 60-degree reference angle. It's -1/2. And then cosine is 1/2, sine is the √3. So this ends up being -2 plus 2i √3. And let's figure out, let's shift 5 cis 30 over. We're just verifying at this point. Showing that it works. This is ugly. Which I'm gonna write as 1/2 times 5√3 plus 5i. Gonna make it easier when I multiply these together. So if I multiply these, I got 1/2 5√3 plus 5i times -2 plus 2i √3. I'll do the 1/2 last. We'll distribute, we got -10√3. And then plus 10i times √3 squared. I'm taking this slow because I don't wanna fuck it up. And then that's doing the outer ones, and now doing the inner ones, I've got -10i. And then I've got plus 10i squared √3. Do some cleanup first before I combine. Square root of 3 squared is 3 times 10 is 30. So that's 30i minus 10i. I squared is -1, so that turns that into -10√3. So combining like terms, we've got -20√3 plus 20i, and then a 1/2 out front. If we distribute the 1/2, we get -10√3 plus 10i, which is what we got up there. It's like magic. Now, if you're not already in fuller form, this doesn't speed shit up. Right? If we started with these two. And took our time to shift to polar, then do it, it's not faster. But if it's already in polar, it's a lot faster to. Just multiply by multiplying the coefficients and adding the angles. Like if I didn't have to convert these to. Rectangular here. This little middle part is covered up. And we're starting right there, and so it's still about the same amount of work. But if I had to actually convert the radians and, or radius and polar first, it'd take longer. That's how the multiplication one works. Any questions? Now, the real time saver is division. Yeah,
What's the bracket?
I don't know. It's. I don't know, I'm gonna think about it, because if we write it as a vector, it's. It's not doing the dot product, because the dot product is not a vector. And it's not doing the, it might be doing the cross product. But I don't think it is, I'm gonna have to look at it. I don't know if there's a real good graphical representation of multiplying, just like there's not really a good graphical representation of multiplying in anything. Let's look at division. So. R1 cis theta 1. Or R1 cosine theta 1. Plus I sine theta 1. Divided by R2 cis theta 2. I'm just writing the expanded versions right now. Just like multiplying led to addition. Well, we're doing the coefficients the same, we're leaving them the same. But multiplying led to addition, division leads to subtraction. Example. 27 cis 45 degrees over -9 cis -180 degrees. Not -9. What am I saying? You're not ready for negative radius yet. We will use it when we graph polar form. It's really just going in the opposite direction. You draw it going the radius pointing in the positive direction, then you flip the vector.
Another question earlier, in that negative value, that was positive on the imaginary axis.
That's fine, when you switch to radius though, it's always a positive distance. Cause the imaginary is represented along the y-axis, there are negative imaginary values. So we just do 27 divided by 9. And then cis of. Make sure you take this slowly, we're subtracting the one on the bottom, which is minus a negative. So we get 3 cis 225. What is that in rectangular? Yeah. Lydia's in the fun zone. What's cosine of 225? About sine of 225. Or. Putting the I afterwards. I'm not sure which way the homework system takes. I'm sure it wants it with the I at the end. You could, if you were feeling. Crazy, factor out the negative 3 root 2. Over 2 and just make this 1 plus I on the inside. D. Alright, let me give you guys one. Wait. I gotta make one that you can get. About to do some shit that you can take a calculator. This one does. I don't think this has a geometric representation. I can't think of vector division. Can't think of anything for vector division. Now, it could be I'm just brain farting. But like for multiplication, we have the dot product and the cross product. Division, I don't think we have anything for, so I don't think there's a geometric representation. You wanna get anything? Go for it.
I got, 5 cis. -60, but it also wrote 300.
Did anyone else get that to start? Well, let's let them work it out and see if you're right. She said 5 says 300. We'll see, but the 180 there is positive. Give everyone else a little bit longer, see if Jordan's completely fucking wrong. Well, let's just write out what it's doing. We're taking the top degree and subtracting the bottom degree. So what's 35 divided by 7? What's 120 minus 180? Looks like Lee, or not Lee, Jordan was right. Is down there. So if you wanted to write it as a positive angle, you could write it as 5 says 300. Alright. That's really all that's in 8.5. I could start 8.6, but 8.6 is gonna like use this system. A lot, like at a harder level, so rather than continuing with it. Why don't we end the lecture here, give you a little bit of time off? Try to work on at least some of this shit over the weekend. If not completely finish your homework on this section, because we are building on this topic on Monday.
And also, so whenever we encounter a negative figure, we should.
It's a good idea. That's all I got for you, folks. GTFO. Or stay here and work on homework and ask questions, up to you.